We're going to again just keep looking at different examples of how we can, write equations using symbols. But I'm going to start by actually dropping down to the bottom of our notes here at the summary. Begin all word problems by defining your variables. Let X be or let whatever be. Say clearly what you want it to be. There's a lot of times it can be written with, a little bit different. Written mathematical statements can be represented by more than one correct symbolic statement. Right here, though. Break complicated problems into smaller parts or try working them with simpler numbers. A lot of times you're going to see me go to the end and then try to come back to figure out the problem. So again, just some more examples. The sum of 4 consecutive even integers is negative 28. Let X be the first, sorry, this is really sloppy, even integer. So it's going to be like in the other video with odd integers, but I'm identifying it as the first even integer. So if I have 4, number 1, that's the first even. 2, 4, 6, 8. That's just an example of 4 consecutive even numbers. So from my first to my second consecutive even number, I add 2. So my second consecutive is x plus 2. And again, I'm using x because if it doesn't necessarily start with 2, it can start 14, 16, 18, 20. We're just going to add 2 to it. When I go from 2 to 6, I'm adding 4. So my next consecutive is x plus 4. And 2 to 8, I am adding 6. So this becomes x plus 6. Again, it's going to be the same with odd integers. We just want to make sure we identify it so we know if we're talking about even or odd. Sum x plus, I'll put them in parentheses this time. It's a little easier to see when we get into solving, though we drop those parentheses, which is why I don't usually write them, but it does make it a little easier. Okay, that sum is, there's my equal sign, negative 28. And the directions just say, write each of the following statements using symbolic language. We don't have to solve. We're done right here. All right, more examples. A number is 4 times larger than the square of half the number. Okay, so what are we talking about here? What are we defining? And I keep seeing a number. So let X be the number. So instead of saying a number, I'm going to say X is 4 times larger than the square of half X. Here's my is right here. Okay. X is 4 times larger than the square of half X. See if it's a little easier when you start taking those words out. So I know it's going to be X is, so X equals. This one here, 4 times larger than the square of half the number. That down here, break complicated problems into smaller parts. That's what I'm doing right now. This altogether sounds confusing. So come to the end. What's half of X? All right, well, half X, multiplication. Now we need to do the square of this. Okay, if I'm going to square the whole thing, I'll put parentheses around it and I'll square it. And then we have 4 times larger. Well, 4 times. A number is 4 times larger than the square of half of X. Again, take it part by part. Another example. Stephen has some money. If he spends $9, then he'll have 3/5 of the amount he started with. Well, let X be Stephen's money. If he spends 9, then he will have 3/5 of the amount he started with of X, of his money. So I'm going to come to the end here, and I'm going to have 3/5 of X. I can write 3/5 of X. I know of means to multiply is 3/5 X. Now it says, if he spends 9, then he will have. That's where my equal sign comes in. He will have it. That's what it has or is or anything like that. So if he has some money and he spends minus $9, he will have 3/5 of the amount he started with. Again, use these little hints. Define your variable. Break it up into pieces. Oh, two more examples. The sum of the sum of a number squared and 3 less than twice the number is 129. We're talking about numbers here, so I'm going to say let x be the number. Notice I always do the same thing, define it. The sum of a number, nope, the sum of x squared and 3 less than twice x is 129. So I know it's going to equal 129 here at the end. So let's start with this part here. What's twice x? Twice means 2 times, so 2 times x. And then we have 3 less than that. Remember that hint, less than, that's where we put it at the end. 3 less than, so whatever it is, minus 3. And then we have the sum of x squared, and that's where the plus side goes. Okay, so we have x squared and 3 less than 2 times the number is 129. And I know I've been doing this for a long time, and I know I can kind of pick up on these things, but I want you to listen to the hints I'm giving. Try it, okay? Because again, as I keep saying, the more you do it, the easier it'll get. And this isn't going away. This is all algebra stuff. All right, last example. Pay attention to this one. You probably will see this again very soon, or a similar problem. Eric is 8 years younger than his sister Tabitha. Eric's brother is 2 years older than their sister Tabitha. The sum of their ages is 120 years. Okay, so notice we're comparing Eric and his brother to Tabitha. So I'm going to let X be Tabitha's age. They both have that in common. So instead of saying 8 years younger than his sister Tabitha, I'm going to say 8 years younger than X. Eric's brother's 2 years older than X. Now in this case, I'm going to use that hint of writing things on the side. We have Tabitha. We know we're saying her age is X. Then we have Eric. And then we have the unnamed brother. All right, so Eric is 8 years younger. So if his sister is 30, he's 8 years younger. He's 22. So whatever his sister, Tabitha's age, minus 8. Eric's brother is 2 years older than X. So if you're 2 years older, we're adding 2. Then we have the sum. Sum means to add. So I'm going to add all these together. Tabitha's age plus Eric's age. Again, you don't need the parentheses. Plus the brother's age. When you add all those together, it is 120. So, again, define that variable. It's actually going to come into handy later when they get even more complicated. Break it into smaller parts. Start with the little pieces you know, and then try to put it all together at the end.